The Science Screen Report, bringing you each month the latest discoveries, developments, and applications of science, engineering, and medicine, made to help solve the problems of modern life. The world's population was 2 billion in 1940. 4 billion in 1976, and may again double to 8 billion by the year 2010 AD. To feed them, world food production must increase by 4% every year. This issue of the Science Screen Report is concerned with efforts in the United States, Canada, and other lands to produce more food for the near future. Breeding better strains of important food crops has long been a basic way to improve crop yield. U.S. State Agricultural Experiment Station plant breeders, by developing hybrid corn, more than doubled world food production of this vital crop. Grain foods, directly or indirectly, feed almost all the world. Today, station plant scientists are breeding new types of grains, which are more pest resistant, give higher yields, and thrive in many environments. For example, some time ago, station agronomists discovered a strain of corn with twice the protein value of any grown until then, identifiable by its translucent outer kernel. Follow-up breeding programs carried out in the United States at the International Corn and Wheat Improvement Center in Mexico have produced more high-protein value varieties. Station researchers also bred high-protein strains of sorghum, the world's fourth most important cereal grain after wheat, corn, and rice, and one of the main foods in Africa and East Asia. Every day, pests destroy crops, pastures, long grasses, and orchards. Food animals and stored produce also suffer their ravages. Agricultural station research teams have developed many effective pest control measures and are seeking new ones through studies of the behavior and life cycles of insect pests. For example, several species of wasp can be helpful in protecting crops from insects. The wasp deposits her eggs in the body of certain larvae. The larvae, instead of hatching, then serve as food for a new generation of beneficial wasps. Weather is the most critical variable in world food production. Excessive moisture, heat and drought, or other extreme conditions such as freezing temperatures and heavy snows are all crop hazards. In many lands, irrigation makes it possible to produce food in arid climates. Where economically feasible, automatic rolling sprinklers have in recent decades turned some dry areas into fertile croplands. For example, for the deserts of Libya, British engineers developed this sprinkler system with its own built-in mobility. The pipe sweeps out a 70-meter green circle of irrigated land. The pipes move continuously, each span driven by its own motor. On suitable level terrain, depending on the particular crop, this system can produce several harvests a year. Trickle irrigation is another technique, using tubes that supply water to each plant's roots. This system helps to save water resources, is adaptable to many types of terrain, and can be used to apply agricultural chemicals. Other experiment station studies are concerned with reversing land erosion, a major world agricultural problem. Wind erosion, for example, can remove tons of soil. Because lands vulnerable to wind damage are being plowed and planted increasingly, U.S. Agricultural Research Service scientists are working to reduce this problem. In greenhouse tests, the scientists check various protective methods, such as special tillage, mulches using cotton trap, recessed planting, and sorghum stubble. The new ideas are tested in a wind tunnel to see how well the plants hold up under the force of the wind. The most promising methods are subsequently tried in the fields nearby. Refinements in agricultural chemicals allow farmers to further increase yields. Specialized fertilizers, for example, have been developed for different crops, terrains, times of year, and points in the growth cycle. Much of the world's land is not suited for crops, but will support grazing. State animal scientists have sought to breed better cattle, as well as to improve animal health. Test programs include embryo transplants to produce greater numbers of superior animals and alternate feeds, such as plant peelings and pulp. This Pennsylvania family farm is using a new service from the State College, computerized analysis of dairy performance. Every month, each cow's diet, health, and milk yield are recorded, and samples of butterfat and protein taken. After computer processing of the data, the farmer gets individualized feeding and breeding programs for each animal. The program has improved some dairy outputs up to 60% and more. Better types of grasses and hay crops for feeding livestock have already been discovered. Station field laboratory teams are now working to apply such practices as fertilization, crop rotation, and pest control to rangeland. Replacing brush and weeds with grasses and legumes has shown that such managed rangelands can support many more cattle and sheep, as well as wildlife. In Canada, gathering seaweed and Irish moss for use in the food industry has gone on for decades. Today, with the help of Canada's National Research Council, Managed coasts are being sought as a way to stabilize seaweed harvesting. Underwater surveys are discovering the quantities and locations of various species. At National Research Council laboratories at Sandy Cove near Halifax, Irish moss is being treated with agricultural chemicals and test-grown in tanks of circulating water, demonstrating that the moss can, with proper treatment, double in size every 2 weeks. Special enclosed bays should eventually make seaweed farming here as stable as wheat farming. In the past century, engineering technology has assumed the tedious, back-breaking job of harvesting from man. Prototypes of these machines were designed by experiment station engineers working with plant breeders who developed varieties that ripen uniformly to make harvesting more efficient. Engineering has also been applied to animal agriculture. With automatic equipment handling most of the watering and egg collecting, one person can now care for thousands of chickens. Other food scientists and engineers continuously seek processing techniques to maximize food nutritive value and purity, as well as solve nutrition problems. Farm products such as peanuts and soybeans can now be turned into a variety of new high-protein foods. Paralleling their scientific research efforts, the stations have also pioneered new ways to disseminate and apply technique. From their beginnings, the stations have worked closely with extension agents who brought new advances to working farmers and land-grant colleges teaching farmers to be. Simultaneously, each station served as a training facility for theoretical science. In recent years, stations have also been classrooms and laboratories to thousands of agro-scientists from abroad. They also serve as prototypes for the 10 international agricultural research centers located in critical climatic regions of the world. Nothing is older to man than his struggle for food. Through development of improved hybrid foods, better pest control, more efficient irrigation, managing food lands, and use of new agro-technology, farm scientists and engineers are seeking ways to alleviate famine and the fear of hunger from the world. Better types of grasses and hay crops for feeding livestock have already been discovered. Station field laboratory teams are now working to apply such practices as fertilization, crop rotation, and pest control to rangeland. Better types of grasses and hay crops for feeding livestock have already been discovered. Station field laboratory teams are now working to apply such practices as fertilization, crop rotation, and pest control to rangeland.